So the chain rule has to do with composition of functions. So let's review how we decomposed functions. So if I have the function h of x equals x to the fourth plus 1 raised to the third, I can break it apart into two functions, f of x and g of x, such that h of x is f of g of x. So here, g of x would be the inner function, f of x would be the outer function. So in this case, I could say, well, g of x is equal to x to the fourth plus 1, and then f of x would say take that function, the x to the fourth plus 1, and cube it, right? So that's going to be my f of g of x. So in this case, the function f of x is just x to the third. So we have to have that same kind of thinking when we do what's called the chain rule. So when I'm taking the derivative of a composition of functions, I take the derivative of the outer function times the derivative of the inner function. Now the notation I find more confusing than just actually kind of working through the problems. Okay, so going back to that original function, I said g of x is x to the fourth plus 1, f of x was x cubed. So I look at this instead and I say, okay, that notation can get a little bit confusing. So instead what I'm going to do is I'm going to put this into a box, right? And I don't know what's hiding inside that box. So this is kind of like that f of x function. So I have f of something, there's my box, equals the box cubed. And to find f prime of that box, you would use your power rule and say this is 3 times whatever's in that box squared. Well, now the g of x is what's hiding inside that box. This is g of x hiding in here. That's g of x, and that's g of x, and that's g of x. So to take this derivative, I would also now need to multiply this times the derivative of what's inside that box. So to write this, h prime of x, I use my power rule 3 times, and that's going to be to the squared, and right here this is just g of x. That's x to the fourth plus 1, but the extra step is now I need to multiply it by g prime of x, which is 4x to the third. So to clean this up, I have h prime of x is equal to 12x to the third times x to the fourth plus 1 squared. So this is what we mean by the chain rule. I'm doing the derivative of the outer function, and then in place of that x, I have to plug in the inner function and then multiply it by its derivative. Let's try another one. Given f of x equals 3x plus 2 squared. Okay, so again, here's my inner function, the 3x plus 2. So to get my derivative, I'm going to work on the outer function, which is just a power rule. So 2 times whatever that thing is to the first. So I'm going to plug in what I took the derivative of there. That's the 3x plus 2. But now over here, I need the derivative of this thing. So the derivative of 3x plus 2 is just 3. And now I'm cleaning this up. So 2 times 3 is 6 times the 3x plus 2 to the first. So I can just write 3x plus 2. And I get 18x plus 12 for my derivative. Okay, now here we're taking f of x equals the square root of cosine x, and we want f prime. When I'm dealing with taking derivatives and everything, a square root sign isn't as helpful, so I'm going to rewrite this as an exponent. So this is cosine x to the 1/2 power. And now I can see this kind of follows my last one. So to find f prime of x, I use my power rule first. So it's 1/2 times the cosine of x, now to the negative 1/2 because I subtract 1. But now I have to do this extra step. This is the chain rule, and I take the derivative of what was here. So the derivative of cosine x is negative sine x. And now I can just clean this up just a little bit. So I have negative sine of x all over 2 square root cosine x. Now, I'm not really allowed to have radicals in denominators, so I would multiply by square root of cosine x over the square root of cosine x. So now I have the negative sine x square root cosine x all over 2 cosine x. I could clean that up and say it's negative 1/2 tangent x squared of cosine x. It depends on the problem how far you actually have to keep going with that simplification. Either of those would be acceptable. All right, so now we have f of x equals sine of x squared plus 1 squared. Notice the angle is x squared plus 1 squared. So this is a combination with the chain rule. So to find my derivative, I know the derivative of sine is just equal to cosine. So it's cosine of whatever that angle is, which was x squared plus 1 squared. But now I have to multiply it again by the derivative of this thing, and this requires my power rule. So this is 2 times x squared plus 1, but now I need the derivative of this inside piece, which is times 2x. So the chain rule means I have to keep taking derivative of an inside of an inside of an inside. And cleaning this up, 2 times 2x, I have 4x times x squared plus 1 times the cosine of the angle x squared plus 1 squared. All right, this one involves, again, the product rule and the chain rule, but in a different order. So f of x equals x times x squared plus 1 to the third. So my first function is x. My second function is that x squared plus 1 to the third. Okay, so when I'm doing a product rule, f prime of x is equal to the first, which is x, times the derivative of the second. So this is chain rule, power rule. So I have 3 times x squared plus 1 squared, but now I have to take the derivative of the inside, so that's times 2x. So I did first times derivative of the second, plus the second, x squared plus 1 to the third, times the derivative of the first. I'm going to clean this up a little bit. X times 3 times 2x is 6x squared, times x squared plus 1 squared, plus x squared plus 1 to the third. Multiplying those out gets a little bit messier. I could factor out an x squared plus 1 squared, and then I'd be left with 6x squared plus 1x squared plus 1. So now I have x squared plus 1 squared times 7x squared plus 1. That's a little bit cleaner and neater for our final derivative.